you. And guys, look at this. These sessions is incredibly important because the thing which is going to happen is that we are just going to build on these small materials which I'm teaching you now, and you are going to, for example, use them in order to some very advanced topics in trigonometry. Then please listen to these materials very carefully. And please, as I asked, please do not talk with someone who's next to you. Just listen and just focus on the content. Okay, now let's get started. Okay, first of all, I can hear some people are talking. Now, look at this. Now, what we talked, I should say, so far, and what you have learned, I should say, the prior years, was that we said that we just start. And Matthew, please never ever walk in the class. Please, yes. And what we talked, I should say, from the prior year was that, and also in the sessions before, we said that we can always identify the things which happens in the universe by just localizing it on the circumference of a unit circle. That's what we have talked so far. We said that the reason that we are learning, I should say, the trigonometry is that it gives us a little more tool in order to localize the things, the events which happens in the universe. For example, if you remember, we said that as a very funny example, we said that if there is a mosquito, which I called it by M, is just wheeling around in the room, always you can localize it in a way that it is located on the circumference of this unit circle. And what did we do was this. We said that, okay, in order to identify this, we know that this point, which is point M, because it is also at the Cartesian plane, it comes with two coordinates, x and y. Now, also we said that because you see that y, it has some x because you can just project it along the x-axis like this. It gives you the x, and you can project it along the y-axis. It gives you the y. You have x and y. What else that we talked was this. We said that besides from these Cartesian coordinates that we have, we can also assign an angle alpha that we can identify this flying mosquito also with relation to this alpha. Then how did we say that? We said that the same point M, it can be written as, instead of x, if you remember from the previous session, because we said that x, which is here, it is what? We said that in the definition that we have, we defined the cosine of alpha. What was the cosine of alpha? Was essentially the adjacent, which is x, over r. Then as a result, you can say that x coordinate of this flying mosquito is essentially r times cosine of alpha. But remember, we said that sometimes we say that the r is going to be equal to 1 unit of 1. It can be 1 meter, 1 kilometer, anything. Then as a result, we said that if that's the case, x is equals to 1 times cosine alpha, which is going to be the cosine of alpha. And that was the first thing that we said. Then as a result, in this unit circle, that the radius is 1, we know that x can be written also as the cosine of alpha. But also, we said that For the same angle, we can define this another ratio, sine alpha, which is essentially the length of the opposite. The opposite is what? Essentially is y, because here is also y. Then we said that sine alpha is y over r. Then as a result, we said that y is r, the radius, multiplied to sine alpha. And because r is 1, then we said that y is going to be the sine alpha. Then as a result, this flying mosquito, it can be written as cosine alpha, sine alpha. Then you see that at any point of time, the moving m counterclockwise can be identified just by these two ratios instead of x and y. That was a thing that we discussed so far. Now, I'm just going now, it was a review that we did. Now, I'm gonna ask you to, no, I'm not gonna ask you, I'm just gonna introduce the new topic, which is gonna be the topic for today. And I hope that everyone listened very carefully. And also, that's the unit circle that we have it right here. Okay. Now, as usual, we have our unit circle. In this unit circle, which I have localized, I should say, one event in the universe. You're going to hear this word event a lot when you also go to university. You can identify anything happens, they call that event. I call that event M. Now we are going to start a very important thing. Look at this. I'm just going to give you one example. This example is a little bit aggressive and harsh, but take it as an example. Look at this. I'm looking at the point M, and I should say, I bother myself, do some measurements, and I find that, for example, M has coordinates as X and Y. And also, I know that it comes with an angle alpha. I take a couple of times, I do the work, and I notice that the point M as an event is localized by X and Y. However, because the circle has a symmetry, I can just do some very interesting things. And what is that thing? Imagine that you are just, sorry, this is that example is very aggressive, but imagine you are going to just, for example, hunt some birds. You pick up one stone from the ground and you see a tree and the birds are just there. You draw one stone to the tree and you expect that you hunt and kill, one bird. But you draw one stone and you see 4 more birds are killed and fall on the ground. And you see, oh my God, I used one stone. I used the energy and calories to draw one stone, but in return, I got 4 birds. And that's the thing that we are going to do. For example, the point M that we got right now, it's going to be the first bird that you decided to hunt and kill by one stone. But as a result, you get also 4 other birds. The first one is what? The first one comes from this. I say that, okay, from the event M, I'm going to draw a line that intersects at the boundaries and circumference of the unit circle. And I do not continue that because I know that beyond the unit circle, nothing is meaningful. Everything should happen just on the circumference. Then I stop here, and this point, which is, I'm going to call this M prime, is going to be the second bird, which I killed it by using the first bird for the M. Why we were lucky to get the second bird? Because what is the relationship between M prime and M? That's right. X is minus and Y is the same. Then you see that we measured only for M, but we could just make an inference about the M prime. I do the same thing. I now start from this point, M prime. I draw a parallel line all the way down until the point that it's not completely parallel, that I just have an intersection with this unit circle. At this point, I stop, and I call this intersection point M double prime. You see that the coordinates of M double prime, because of the symmetry of the unit circle, is as if the axis is minus, and also you see that the y also is minus. Then you see that in the third quadrant of the Cartesian plane, because of the symmetry which is introduced by the circle, we made one measurement at the first quadrant, while we were able to just get the similar measurements at the third quadrant without going to the field and take the measurement again. Now, I'm going to continue the same thing. I say I'm just going to start from M double prime, draw a parallel line to the x-axis, and I go all the way that I have an intersection with this unit circle. And at this point, I call this point M triple prime, which you see that it has one same x, but the value of the y is minus y. And now I can see that I can go back all the way to the point M if I have another parallel line to the y-axis. Now, then the point is that you see that by the symmetry which is introduced by the unit circle, we can only make one measurement for the M, but we get another points. Now, let's connect them with the concept of the angles that we have learned. Any questions so far?
No.
Now, look at this. The point M prime, it makes an angle with the Cartesian plane if the fixed arm of the angle is OA, M prime O is essentially a moving arm. You see the angle over there. AOM prime is an angle. What kind of a relationship does it have with the alpha? We talked about a little bit about that before we left last session. We said that the point M prime is located with the angle which is pi minus alpha. This is very, very important because I'm going to show you when we just go for the numerical example, you see that the things that we are talking right now, oh my God, they are so important. Then you see that at the second quadrant, listen very carefully. If you're located at the second quadrant, you have pi minus alpha with respect to the alpha as a reference angle. Now, I'm now moving to another point. With the same angle, I make another angle, which has this, again, OA is a fixed arm. And you see that here, the angle which is created between AO and prime is how much? Now this is pi. Sorry, did I talk about pi before? No? Okay, sorry. Let's, instead of pi, let me use 180. This is 180 minus alpha. And for this one, this is 180 plus alpha. Alpha is in degrees. Now also, look at this. I'm gonna build another angle which is connected to M triple prime. And you see that the angle which is built all the way going to here you can see that it is essentially equals to 360 minus alpha. Yes, because we started with the alpha here, which I called it as a kind of a reference angle. What is that? This is the first bird that we killed. We had to just find, for example, we have an event. We find that event on the unit circle, and we identify the points X and Y, which essentially they represent event M. Then from these points, without going to make any other measurements, we can find the coordinates of M prime, M double prime, and M triple prime. Now, this is kind of, I should say, a very rough idea of what we are gonna do. I'm just gonna give you one numerical example, then we see that what these things mean. But this is a very important thing. I hope that everyone has a very good, I should say, sketch of this unit circle, because we're gonna use that in the next 5 minutes a lot. Any questions so far? Now, then the good thing is that before I just go on to have some numerical value for you, is that if we have one event happening at the first quadrant, by knowing the angle, I can make 3 other measurements: M double prime, M prime, and M triple prime. That's the key message from this slide. Now, but why do we have to learn this stuff? What's the point? For example, look at this. I say that, okay, I'm just coming here to give you this. And I say, I have an angle now. This angle for me is going to be, give it a typical value that we have talked about this before. I say that we have an angle here, which is defined from AO as a fixed arm, extending to OM, then we have an angle AOM. We say that it is 30 degrees, right? Now, we said that also we have a unit circle, which means that the radius of that is 1 unit. I can ask you, okay, we have this flying mosquito has been located into the space while it was making the angle 30 degrees. And locate that mosquito for me. You say, okay, this mosquito should comes with one value of the X and comes with one value of the Y. That's obvious. And based on the thing that we talked about this, on this slide, you see that this mosquito with the coordinates X and Y can be connected with the angles which they make while they are flying around the circle. But this angle here right now is 30 degrees. Then as a result, we say that this flying mosquito, which is flying around counterclockwise of this unit circle, can be located as cosine of 30 degrees and sine of 30 degrees. Does it make sense so far? Yeah. Everyone is okay so far? Nice. Now, then I say cosine of 30, sine of 30, what they are, for example, when it comes to the test, or for example, when I talk to you, you are doing your homework, you do not have to leave cosine 30 and sine 30 there as the way they are, because they are so important. They are the celebrities of the trigonometry. For example, one of you say that, for example, I like Jennifer Lopez, for example. Everyone knows Jennifer Lopez, huh? Cosine of 30, this is like the Jennifer Lopez of the trigonometry. Everyone knows about it. How? How much is cosine 30? How much? That's right. Look at this. How did we get that? We said that in order to get cosine of or sine of 30 degrees, what do we do is that we build a right triangle. Never try to memorize it. Learn how to make it and answer it then. I never memorize this stuff. I always do this one. I always build a triangle, a right triangle for angle 30 and 60, yes.
Will there be a chart for the
Sorry, what?
Will they give the degrees?
Oh, normally it's 30, 60, and 45 degrees. They are the most popular one. These angles are like the Jennifer Lopez of the trigonometry. They are so popular. Everyone knows about them. Yeah, no, you can also drive it as what I'm going to do right now. No need to memorize it. You can drive it. You say that for 30 and 60, you say that if imagine it's going to be 30 angles, 30 degrees, what is the other angle? 60. Thank you. And what do I do is this. I say, okay, the length next to adjacent to 30 is going to be, let's say, for example, square root of 3. And in front of it, it's going to be 1. Then you see that the hypotenuse is how much? 2. Thank you. And yes.
Will we always be given
The length? No, the length can you work with them a couple of times because one of them is always 1. You can always find this one using the Pythagorean. You write 2 times, you can memorize these ones.
like, will it always be?
Yes, always. Because that's the right triangle. And from this triangle, we find the ratios of 30 and 60, as we had the 2 sessions before. This one is just a unit circle. It's just a right triangle. Now, Matthew, what I'm going to do is this. I'm looking for the 30 degrees. I'm going to write the ratios for 30 degrees. I say cosine of 30 based on the definition that we know is the adjacent, which is the square root of 3 over the hypotenuse, which is 2. And I didn't do anything except I used the definition. It's the recipe for the cosine. You always say that. The cosine of any angles is the adjacent to that angle over the hypotenuse. And also, we see that the sine of 30 degrees is going to be, based on the definition, is going to be the opposite length, which is 1, over the hypotenuse, which is 2. Now, then as a result, you see that the point M, it's cosine of 30, which is the square root of 3 over 2, and 1 over 2 for the y. Then now, what did I do so far? I located this flying mosquito when she was flying on the air, but at the same time, she was making the angle 30 degrees. Now, that mosquito is located at square root of 3 over 2 along the x and 1 over 2 along the y. That's now what we have done. However, I'm going to go back to do the same thing which I did on the previous slide. I said that, okay, from this flying mosquito, I'm going to draw a parallel line with respect to the x-axis until it crosses the circumference of the circle. When I'm there, I build this angle. What is this angle, guys? Remember this slide. We said that 180 minus alpha, it finds you at the second quadrant on a point at the circumference which has the same characteristic with M. Now I have 30. 100 minus 30 becomes how much?
180.
Yes, 180 minus 30, 150. I get for this angle 150 degrees. Now, I locate this point. The mosquito has a mirror image. I call it M prime. Now, Can you tell me the location of the mosquito at M prime? How much is that?
Minus square root of 0 over 2 and over 2.
That's right, because as you remember, thanks, Lucas, because now we are looking at this. We said at the second quadrant, only the x changes the sign. It becomes then minus square root of 3 over 2. But the y is going to have the same value. Yes, Matthew. Of course, please. Now, then as a result, if I ask you, for example, something like that on the test, what is the cosine of 150? Do you know how much is the cosine of 150? That's right. Thank you. Minus the square root of 3 over 2. How did I find this? Because I noticed that I can find the angle between 30, 60, and 45, which they are the Jennifer Lopez of the trigonometry. Always we can relate other angles to that. 150 becomes like 180 minus 30. And it locates on the second quadrant. Then as a result, by knowing the location of 30, we can find 150. Look, it's going to get even much funnier because I'm going to draw the same parallel line with respect to the y-axis. I stop right away at the intersection of this line with the unit circle, and I call this M double prime. Now, look at this. There is another angle is built here. And now look at this one, guys. I built an angle right now because of the symmetry. The angle is here. This green angle between AOM triple double prime. Now, at this point, what is the coordinates of M double prime because of the symmetry?
Minus x minus 5.
Minus x and minus 5. It means that minus square root of 3 over 2 and minus 1 over 2. You see, I didn't have to measure anything. Just by knowing the first value, I was able to make an inference about this. Yes.
But then don't you 180 plus 30?
That's a good point. I'm going to do it now. That's a brilliant point. And look at what is the angle, the green one. That's right. Why? Because we said that based on this slide, we said that if we are located at the third quadrant, we add 180 to the reference angle which we had. Yes.
Could it be a test question, like if you're given an angle, like, for example, if you're given M double prime, and they ask you to find M by itself?
Of course, that's what we do. Of course, it's going to be a kind of a test question. We're going to do more example on it. Now it's the building block. Good question. Now this angle becomes how much? 210 degrees because it becomes 180 plus 30. Then as a result, if I come and ask you, what is the sine of 210? What do you tell me? That's right. You say that 210. Let me think, how can I just convert it into the celebrity of the trigonometry? I can say it can be written as the sine of 180 plus 30, that it equals to minus sine of 30. Sine of 30 is 1 over 2, and you see that we have minus 1 over 2, becomes minus 1 over 2. Make sense, everyone? Now, look at this. Now, we are going, let me pick a different kind of color. Let me choose this. Now, I'm going to do the same thing, a parallel line with respect to the x-axis. Yes. Of course, please. And now I make the angle like that. Now, the blue line, which we have, it represents this angle, the blue one. Which would just take us to the point M triple prime. What is the location of M triple prime, X and Y? That's right, the square root of 3/2 and minus 1/2. We just got it from here, just right away. What is the angle for it?
360 minus 30.
360 minus 30 becomes how much? 330. Then you see that as a result, the cosine, for example, if I ask you, what is the cosine of 330? What do you tell me? You say, wait a minute, how can I relate it to one of the angles, which is 30, 60, and 45? I say, the best way I can write it as the cosine of 360 minus 30. It takes me to the second quadrant, sorry, the fourth quadrant. The fourth quadrant, the cosine doesn't change the sign. Then it equals to cosine of 30, which is equal to the square root of 3/2. Then you see, when we have one angle, we can right away find another values for it by just finding the symmetry along, I should say, the axis. And you can all the way go back to the M by having a parallel line with respect to the y-axis. We got to the same point that we got. Any questions? No, everyone is good? Yeah. Now, the thing that we want to do right now is that I'm going to give you one problem that you solve it as what I did. You can take 2 minutes break then to refresh your mind, but make sure that today you solve it because next session we move on to a different topic. Now, I'm going to do the same thing. I'm just going to draw an X and Y coordinates. What else I'm going to do is that I'm going to have this unit circle there. And from this unit circle, I'm going to have a line. I localize an event in the universe and I called it as usual M. Remind us of that flying mosquito. However, I say that this is located. While we look at this flying mosquito, we said that this mosquito is localized at 45 degrees with respect to the x-axis. Then the angle AOM is 45 degrees. Now, what I want you to do is this. You do the exact things which I did right down here. Identify all the symmetrical points and find the localization of each point that you find that numerically. And remember, 45 degrees is a very popular celebrity. We have to know everything about this. And we talked also about that 2 sessions ago, how to find the sine and cosine of 45 degrees. I'm gonna stop it right now here. We take 2 minutes break, then we come back to do this. Give me 1 second to stop the recording, and I just share this. Just gonna resume the recording. And guys, remember, I'm just gonna give you homework for the first homeworks for the trigonometry. And remember, you're gonna see lots of angles there, lots of angles. You have to remember, you have to always be able to connect them back into 30, 60, and 45. And that's the key. Now, we do this as a very last example. Okay, we see that for point M, we can locate that, and X and Y, But what are the x and y's for this 45 angle? This is one of the right triangles that we talked about that, I should say, last session. And we said that it's worth to memorizing, I should say, and learn how to derive the ratios of 45 degrees. I say that for the 45 degrees, if this acute angle is 45, how much is this angle? That's right, both of them are 45 degrees. The length also should be equal. If one length is 1 unit, of course the other length has to be 1 unit. And you use the Pythagorean theorem, you see that the hypotenuse is going to be square root of 2. Good timing, we just started, no problem. Now, for the 45 degrees, what we say? We say that the cosine of 45 degrees is what? Is adjacent with respect to the hypotenuse, which is 1 over a square root of 2. And as we talked about that, we said that Simon, we said that the umbrella, which is the square root of 2, is just on the ground. We have to take it up. We have to take it up, not to get, I should say, so. Then I multiply both sides by square root of 2 over 2. What we get here is the square root of 2 at the numerator. At the denominator, it becomes, we have two people walking together with two umbrellas. We only share one umbrella, and these two people just come inside. That's called normalization. When we see that the square root at the denominator, we do the normalization, we bring it up. Like the umbrella, you bring it up. Then as a result, you see that becomes the square root of 2 over the square root of 4 becomes 2. You do the same thing for 45 degrees, and you get the exact same result. Then we say that this point M is located at square root of 2 over 2 along the x, and also square root of 2 over 2 along the y. Now, what else? We say that, okay, we can do the same thing. We can build this symmetrical angle. We said that this point M prime, which takes the angle how much? 180 minus alpha. Alpha is 45 degrees. 180 minus 45, how much? That's right. We say that the angle 135 is connected to the reference angle 45 degrees. But the x-axis is connected to minus the square root of 2 over 2. But the value of the y, they share the same value, square root of 2 over 2. Any questions so far? Now, we used another symmetry. We connect it here, we find another angle. We said that this angle here, which is located at the third quadrant, is showing me the point M double prime. How much is the angle? That's right. It becomes 180 plus 45, which is 225 degrees. Then we see that the x is minus the square root of 2 over 2. And the y is how much? That's right. Fantastic. Both of them are just behind, I should say, the origin. And lastly, I'm just going to build another symmetrical angle, which is highlighted by this angle, the green one. And it gives me the point M triple prime. How much is this angle?
315.
How much?
315.
315, that's right, because 360 minus 45, 350 degrees. Then it gets the cosine as the same thing, x remains the same thing, but y has just changed the sign. Then as a last question, guys, I'm gonna ask you, before we leave, I'm gonna ask you, how much time do we have? I ask you a question which the answer takes maybe 2 seconds. What is the tangent of 315? Imagine that's the key on your test. Without using the calculators, tell me what is the tangent of 315? Takes 2 seconds to solve it. Yes. That's right. We know that the definition of the tangent is sine of the angle 315 over the cosine of the same angle 315. Sorry, not 315. Yes, 315. And that's the first point. Yes, Ella. It's -1. That's right. Look at this. What is the sine of 350? That's right. We say that, okay, sine of, that's good, right? Because we say that 315 is not a popular angle. How can I connect it to those celebrities? I say 315 is at the 4th quadrant. Then I can say that it's going to be 360 minus 50, which is how much? Square root of 2 over 2. Sorry, it becomes the sine of, sorry, it's 45. Look at this. 315 is 360 minus 45. Right? What's the point of doing this? 360 minus 45. Look at this. It gives you 315. Simone. Look at this. 360 minus 45. It gives me 350. Watch now. This is connected to 45, which is a popular one. That's what I know. You know, I had no idea who is 350. But when I write it 360 minus 15 minus 45, I say, oh, look at this. I know 45. That's the Jennifer Lopez. I know her. Now, it's equals to what? Minus sine of 45, which we got it from here. The sine of 350 is how much? That's right, minus square root of 2 over 2 divided by. And also we have cosine of 360 minus 45. Look at this, everyone. Still we do not know 350, but we know 45. Then this one is equal to what? That's right, because why? Because 350 and 45, they are connected. 36 degrees minus alpha. And they, you get this, they give you the same value of the x. You see this?
But you can also look at your results from.
That's right. Then at the end, it becomes the square root of 2 over 2 becomes -1. Let me stop the share.